Hi there. I just wanted to take a few minutes to share with you an example of a chi-square test of independence. This could be helpful for your project and for completing some of your assignments. So here's our example. It says here on October 15th, 2020, a Gallup poll asked 1,014 U.S. adults, do you think the use of marijuana should be made legal or not? The results are in our table below. So we have the three age groups that they classified the respondents into, and also their yes or no response to marijuana being made legal. It says here to use a 0.05 significance level to test if age group is related to legalizing marijuana. So the data for this example, as we move through it, you might want to go and grab it from our class repository. It's called Age and Marijuana, and is in our class repository in our Guru. So the first thing I want to do is kind of visualize the data. I like to do this when I do hypothesis testing. Is just kind of look at the data and see what it's telling us. This is just descriptive stats, but it's kind of nice to do that. So what I did was I took the three age groups and I just made bar plots of their opinions on the marijuana. You can see I've made a relative frequency of this. That's my vertical axis here. It's not a frequency count, but a relative frequency, because what I noticed here when I looked at the data was that there's a very different number of respondents at each age classification. The 55 plus has well over 100, close to 100 more than the other two groups. So I thought we could look at this. And we can kind of see a trend here. You can see that as the age groups are getting older, the yes bar is getting lower. I will say it's always over 0.5, but it's certainly going from a little bit above 0.8 here. The middle-aged people, it's about 0.7 or so. I can't tell exactly, but we can look at that later. And then there at 55 plus, it's over half, but it's definitely declining. So I'm wondering if age group has something to do with their opinion on legalizing marijuana. So here are hypothesis statements. We mentioned in class that age and group wanting to legalize marijuana are not related. So we put the names of the row variable and column variable into our hypothesis statements. They aren't symbolic. They're literally a sentence. And then the alternative is the opposite of that, which is age group and wanting to legalize marijuana are related. We have assumptions and conditions we want to think about for this problem. We want to make sure, as it mentions there, we're random sampling, we have independent samples. So each person's opinion is independent of the next. And the last one looks a little weird because it's a new kind of a condition, and that is that we have a sample size large enough such that the expected frequencies are greater than 1, all of them, and at least 80% of them are greater than 5. So I want to compute these expected frequencies for you because right now, as you read this might make absolutely no sense. So the next slide is the calculation of the expected counts or the expected frequencies. So I'm just going to take this first row here. These are our 18 to 34-year-olds. And what's above, beneath yes and no, are the observed counts that we saw there. 241 said yes, and 53 said no. So if the null hypothesis is true, and we always assume the null hypothesis is true until we can find data to say otherwise, then we would have expected 200 yeses and a roughly 94 no. So that 294 would have been split up in this fashion. 200 saying yes and 94 saying no. And you can see right there that our observed counts aren't anywhere near that. Let's look at our 35 to 54-year-olds. Again, assuming the null hypothesis is true, this calculation down here, this is how we find expected frequencies or expected counts. We would have expected 214 to have said yes and 100 to have said no. That would add up to our 314 people. And as you can see in this particular row, those numbers are quite similar. And then we could do the same thing for the last row. So the test itself is trying to figure out how different is our observed counts that our data gave us from what we would expect to see if there's no relationship. So a collective measure of that. You can refer to your textbook for the formula and such, but that is our expected frequencies. Now, the yellow numbers here are the expected frequency. I put them in yellow just to draw attention to them. And you can see they're all well above the number 5. So we have no problem checking that a condition off and saying that that our assumptions and conditions are met. So let's go to our guru, because we're going to accomplish this hypothesis test using our guru. Here we are. So we're in our guru. You will want to have already downloaded or imported the data set. Go to my groups, show your groups, go to the repository and grab age and marijuana. I've already done that for the purpose of this video being not so long. So we're going to go to analytics here. So when you arrive, it'll be closed up. Open your analytics panel, click on analysis, and let's go to contingency table. So the first thing we're going to do, we do have raw data. We're going to select our data set, age and marijuana. Once we select the data sets, we'll have access to the titles of the columns, age group and legalized marijuana. It really doesn't matter which one you choose as factor 1 and which one you choose as factor 2. The chi-square test will be the same either way. Then we're going to have to give it a nudge and tell it to do the chi-square test. Otherwise, it just kind of gives you your table and won't do a statistical analysis for you. So tell it to do the chi-square, and that's pretty much it. You can adjust your significance level if you choose. Ours was 0.05, and that's the default here. Let's preview our results. So as you can see, you can double check that it matches the table that you have in the problem, that you indeed have the right data and have communicated your variables to our guru. And when we go down below that, we have our chi-square test of independence. So this is our observed test statistic, our chi-square, rather large at 46.6. And then here is our probability value. We'll talk about that in a minute because that probably looks a bit peculiar for you, all zeros. If I scroll down to the bottom of the page, here are the expected counts. So if you ever need to check an expected count, compute one for some reason, you can always utilize our guru, and they have these expected frequencies or expected counts at the very bottom of the output page. All right, let's head back to our problem. So here we have our observed test statistic, just repeating and cataloging what I found from our guru. And here is the p-value. You're like, why is this all zeros? Well, it's because it is a really, really tiny zero. It's like a very, very small value. I should say tiny zero. It's a very, very small value, smaller than the number of decimal places they choose to show in this column. So we have 5 decimal places, so the p-value is much smaller than that. Matter of fact, if you were to scrutinize that output a little bit more and look at every single part of it, it's actually 7.5 times 10 to the 11th. So it's so small, they put it in scientific notation. So extremely small. So if we going to go make our decision here, utilizing our probability value at essentially 0, and compare that to our significance level, which is 0.05, I think we can see that our probability value is less than, much, much smaller than 0.05, which means we are to reject the null hypothesis. Okay, so we have our decision here based off of our sample data, being quantified, doing a test of independence on it. So I always like to rewrite or at least re-examine my hypothesis statements when I go to the last step. And so I have them there. And again, our decision was to reject the null. So I literally cross it out, meaning that my eyes can't see it. And I'm left with the alternative. And the alternative literally says to us, the age group and wanting to legalize marijuana are related. So that's the hypothesis that the data is consistent with, more consistent with the alternative than it would be with the null. So our statement is a little easier to write here because pretty much half of it's been written for us because our all hypothesis statements are full sentences. So our statement would say there is sufficient evidence to support that age group and wanting to legalize marijuana are related. So that's a nice example to use to help you through homework assignments and your project. Reach out if you have any questions.